right. Hello, welcome everybody. Good afternoon. Thank you all for being here. Welcome to October's Planning Lunches at Noon webinar. We're here to learn about, we've got the outreach session for updated New Hampshire Stormwater Manual, which is very exciting. I'm Brendan McDowell, a principal planner in the Office of Planning and Development at the New Hampshire Department of Business and Economic Affairs. So before we get into things, here's a reminder on how to use Microsoft Teams webinar controls. Please put your questions in the chat, and we will do our best to answer them. Yeah, so you'll see the controls there. So just put everything into the chat as we go through. And with that housekeeping out of the way, go ahead, Deb. Take it away.
Great. Thank you, Brendan, and welcome everyone. On behalf of myself and my co-presenters, we're really excited to be here today. We're honored to be able to take some of your valuable time during lunch. And so today we're going to talk about the updated New Hampshire Stormwater Manual. So a few good housekeeping items from our end very quickly is that today your presenters are represented by the New Hampshire Department of Environmental Services, UNH Stormwater Center, and CEI. We are going to ask that you hold your questions until the Q&A portion, which we've allotted a sufficient amount of time at the end of the presentation. However, as Brendan had mentioned, please put your questions in the chat or your comments in the chat as each of us is presenting, because we will be referring to those during the Q&A session. And then during the Q&A session as well, we'll probably be using the raise your hand option too. This session, as Brendan had mentioned, will be recorded in addition to be posting on the BEA website and the variety of platforms. We are also going to be posting it on the UNH Stormwater Center website as well. So I just want to give you an overview of what you can expect today. I hope you are all as excited as we are. We're going to give a little bit of an introduction to the team who was so valuable in putting this new stormwater manual together, some of the funding sources, some of the background, and then a high-level overview of the stormwater manual and its content updates. We won't be able to go into elaborate detail. That would take us hours, but we're hoping it's enough of a teaser that you're going to want to go and really delve into the manual. We're also going to talk about the alteration of terrain, or AOT crosswalk. We're going to talk about technical examples. We're also going to show the applicability to the MS4 permit compliance and municipal resources. We'll talk about next steps. And then again, as I mentioned, we've allotted a lot of time at the end so that you can ask your questions and provide comments. So the presenters, let me just take a moment because without this team, we would not be here today. And this team here was very instrumental in preparing the updated stormwater manual as well. So again, my name is Deb Loisel. I'm the stormwater coordinator here at the New Hampshire Department of Environmental Services. And as the co-presenters, we have Dr. Jamie Houle, who is the director of the UNH Stormwater Center, David Roman, who's a principal engineer with CEI, and my colleague at DES, Mike Schlosser, who works in the AOT Bureau Land Resources Management. All right, let's get into the introductions. We couldn't have done this without the wealth of people that were involved. And so I just want to take a moment and acknowledge and give a big thank you to a variety of individuals. I won't go over everybody's name, but just in a general sense, first I want to thank the manual project team. Again, as I had mentioned, the core team is with you here today. There were representatives from New Hampshire Department of Environmental Services, CEI, and the UNH Stormwater Center. I also want to send out a big thank you to my colleagues at DES. You will see the very lengthy list of all the individuals that were involved in reviewing each and individual components of the stormwater manual. And we also did involve the Stratford Regional Planning Commission for some input as well. Last but not least, a big thank you to our stormwater expert panel reviewers. They're the ones that reviewed the final draft after it went through all the variety of review with the individuals that I just mentioned. And you can see here, we really reached out to make sure that we got that input and the appropriate input. So you can see we have individuals from the Environmental Protection Agency, uh, several New Hampshire municipal folks, New Hampshire Department of Transportation, again, more involvement from New Hampshire DES, and then consulting firms. So a little bit of background is, first of all, why are we here? Well, we have this phenomenal manual. It's only about 8 months old. We published it in February of 2025. It had been years in the making. And we want people to use this very valuable resource. It contains a lot of really good information on how to address stormwater management, stormwater quality issues, and we want to make sure that everybody understands and knows that it's available. We can't expect you to know what you don't know. Next, why was the manual updated? Well, it was over 15 years old. By the time it got published, it was 17 years old. So as you can imagine, the state of the science was old. The rules and regulation references were old. The original manual was a phenomenal tool, but it just needed a lot of updating. So we're really excited to be able to share the updated manual with you. Talked a little bit about the process, or actually I talked about the people that were involved. But this first started out with a needs assessment. So the project manual team collaborated with project team and stakeholders. We actually went back to the stakeholders that were engaged during the 2008 manual. The majority of them were still around. Some had retired or moved on, but we made sure we got the representation from those pertinent entities. And then, like I said, we had a lot of involvement with the DES folks and others, and then ultimately the expert panel reviewers. So really what I just want to let you know is that we did not develop this in a vacuum. It took years and we put a lot of thought and we had a lot of collaboration. So how's the manual going to be managed and updated moving forward? Because we don't want this update to last 15 years again. We all agree that it needs to occur more frequently. So the plan is that we are going to update this periodically. Our goal is every couple years. And this will allow us to update rules and regulation references and also the state of the practices. So as those advance, we'll be able to almost immediately put those into this manual. So you have the most current data. I also want to acknowledge the funding sources because quite frankly, one of the main reasons this manual was not updated for so long is because we did not have the funding sources to do so. So many thanks to EPA with the two funding sources that came from the Clean Water Act and also the Clean Water State Revolving Fund that went through here with the New Hampshire Department of Environmental Services. I also want to acknowledge the outreach funding. So this type of session and outreach and many others that we're doing in order to let everyone know about this phenomenal resource would not be possible without the New England Environmental Finance Center and the strong collaboration with the UNH Stormwater Center. So thank you, New England Environmental Finance Center, for making this all possible. So what does the 2025 manual provide and why should you care and why should you be so interested? Well, it's a technical guidance compiling the state of the science and recommendations. And again, it also references the pertinent state and federal permitting programs here within the state of New Hampshire. And we know that a lot of you are referencing this and you're wanting to know, like, well, if I have project X, what do I need to know for pertinent state and federal permitting? So this is going to be like a really kind of a go-to for you to do that quick check hopefully, and make it easier for you to maneuver through any permitting process that you will need to do. The one last thing, and this is something that came up when we released the manual, there was some confusion. Um, it's really important that you understand this is a guidance document. This is not a regulatory document. As I mentioned, there are state and federal permit rules and regulations contained within it that are regulatory, but the manual in and of itself is guidance only. And that was the same with the 2008 manual. So we just wanted to make sure that everybody understood that. Now, that doesn't mean that if you're a municipality, you can reference this manual in your rules and regulations to make it regulatory, but the manual, again, in and of itself is guidance only. So regarding the manual stewardship, in 2008, the original stormwater manual was stewarded by New Hampshire DES. And as we were developing this new manual, we realized for a couple of reasons it was most applicable to be stewarded and housed by the University of New Hampshire Stormwater Center. We will continue to work very closely with them, and we'll continue to make this a collaborative process as we update the manual. But this is now going to be owned and stewarded by UNH Stormwater Center. The other big reason for doing that was because it gives us the capability of updating the document more frequently. You'll note there, and you'll see a QR code that will bring you right directly to the stormwater manual. And there's also a link. And I noticed that in your chat, you can also grab the link to the stormwater manual as well. All right, I'm done for now. I'm going to pass it over to Dr. Jamie Houle. Thanks, Jamie.
All right, thanks, Deb. And hopefully everybody can hear me. Yeah, I'm Jamie Houle, Director of the UNH Stormwater Center. So it was a pleasure and our pleasure to be the steward of this great document and also to work with this really dedicated team. And what I'm going to do is just do a brief overview of what's in the manual. And then Dave will do a deeper dive into some of these sections. So next slide. Obviously, a 15-year-old manual, a lot changes in those 15 years. And on the stormwater side, one of the things that's engaging and exciting about the stormwater field is the science is constantly changing. And so we were able to reflect the updated science in this new manual and forward some concepts that we hope, proof's always in the pudding, but we hope help you recommend different design practices that are better or more targeted to meeting your strategic goals for water quality and water quantity control. In addition to these new concepts, you'll see the whole look and feel of the manual has dramatically changed. We're introducing new topics, things like emerging contaminants and climate change, and then we're updating design criteria and methods for the actual post-construction control. We also have updated the erosion sediment control. So during construction, there's a range of different stormwater control measures and BMPs that need to be advanced to protect water quality, and we've updated those sections as well. And as you'll note, the overall formatting is different and updating. Next slide. All right, so as far as new concepts, the idea here is it represents what the science is pointing towards is the most effective approaches to manage stormwater. So this is a guidance, as Deb had mentioned, that can be incorporated into site plan review regulations and other planning regulations and local ordinances that advance water quality goals and help communities meet the challenges of today and future scenarios. So in some cases, this represents kind of the future or where the science is going. But in a lot of respects, as hopefully you'll see, it's very consistent with some of the updated documents. So in New England, like I said, stormwater is fast and the science changes. We also, in New Hampshire and Massachusetts, we're non-delegated states. So EPA Region 1 writes our permits for us. And so our permits tend to be more progressive anyway. And so the guidance in this manual is very consistent with some of those emerging criteria. We should note that these kind of state of the practice are identified throughout the manual by this New Hampshire Plus icon. And we just added that so that you understood or were aware that, this might go above and beyond what's required. But again, we're looking at this as the most protective elements of stormwater design that are available today. Next slide. Well, you'll also hear about this watershed protection standard. This is largely guiding on-site stormwater management, or what we have the old manual referred to as groundwater recharge. I mean, that's the primary way to manage on-site rainfall depths. And so Dave will go into greater detail about what this is and what this is referring to. And again, it's very consistent with the updated Mass MS4 permit that came out in 2024. New Hampshire's permit will come out probably sometime this year. And the New Hampshire and the Mass permits are, at least the existing ones, are almost identical. So we really feel like this will be very consistent with the new permit as well. And it's also consistent with the recently updated Mass draft manual that has a 1-inch retention standard. We are calling this a watershed protection standard because we're engaging new modeling and up-to-date ways to model this on-site retention. And we develop resources, as you'll see, to help you and guide you through that. So we really hope that we're making this as easy as possible to adopt and provide tools to engineers and designers that are going to be doing this throughout your municipality or throughout your jurisdiction. And the goal of the watershed protection standard is really to meet the pre-development, from a hydrology perspective, the pre-development hydrology. So from, the drop of waters perspective, the goal is the same as in the pre-development condition. And we can do that through advanced engineering and the advanced practices that we're putting forward in this manual. Next slide. Of course, any updated field, I mean, the acronyms are how we measure our success sometimes. We are adopting a new acronym for best management practice, and that's called stormwater control measure. Why? It's mainly because EPA has adopted this as well. And, if you look across some of the other updated manuals, they're all moving towards stormwater control measure. It's a little bit more precise. Best management practice is very vague and open term. These things are still applicable to erosion and sediment control practices, but the structural and non-structural practices for post-construction, which we'll spend the majority of our time going over, needed a little bit of an acronym update. So that's what we're calling stormwater control measures. Next slide. And as I mentioned, we don't do this work in a vacuum. It is very integrated with other things that are happening in New England and very tied to the updated alteration of terrain guidance or regulations that are out there. The recently updated construction general permit, the EPA CGP, that governs construction activities, and then the MS4 permit. So the 2017 in New Hampshire and 2016 Mass permit, which again, like I said, are written by EPA Region 1 and are almost identical because Mass and New Hampshire are 2 of the 3 remaining non-delegated states. And as I mentioned, it's also very consistent with the draft 2024 EPA Mass MS4 permit, in addition to some of the other things that we've seen emerge since, like the residual designation or the CII, the commercial, industrial, and institutional permit that came out for the three urban watersheds in Massachusetts, the Mystic, the Charleston, and the Ponset. Next slide. As far as new topics go, we address harmful algal blooms. If we look at, 2008, when the manual was written, it was largely focused on sediment. Now, I would say this manual, one of the most dramatic changes is very, very focused on nutrients. So phosphorus in inland freshwater areas and nitrogen in coastal areas, as those tend to be the limiting factors for these harmful algal blooms. We also address emergent contaminants, things like fluoroalkyl substances or PFAS, a climate adaptation and resiliency, and other really smart ways to advance municipal stormwater management, like asset management programs, illicit discharge detection and elimination. There's a lot of resources around those that are available through the manual and linked through the manual. The Green Snow Pro as a way to address fluoride, and other public education and outreach activities that are all kind of referenced and available as links in this resource. It also discussed up-to-date grants and funding opportunities, and we've added this new section around retrofits. Retrofits being areas that you might be doing and implementing to meet water quality objectives or water quality requirements, but are not necessarily associated with new development or redevelopment projects as defined by the municipality. So these would be things like the municipality might be doing on their own, or things that are just being done to improve the existing standards, but are outside the development context, the regulated development context. Next slide. And I believe this is where I hand it over to you, Dave. Is that right?
We can definitely do that. Yeah, it was.
Okay.
Yeah, it was a bit further on, but this
Okay,
is fine.
I can keep going.
Okay.
Sorry, I thought for some reason. Well, stop me when I go too far, because I've done that too.
Okay.
So I'll spend another minute talking about the watershed protection standard, and I'll drop in the chat kind of where this all sort of emanated from. It was largely a study that was done by EPA Region 1 in the Taunton watershed called the Holistic Watershed Management Study. And I dropped a link to that. You can find more in-depth information on this. The real underlying criteria here is when they looked and they modeled existing standards with respect to groundwater recharge requirements or on-site retention, they weren't meeting the criteria, overall criteria under the Clean Water Act that is, shall not cause or contribute to the impairment. So, they were finding that it wasn't really adequate, not just to control, future development and climate change scenarios, but even the existing management. So we've updated that, and that's what we're calling the watershed protection standard. It's very similar to the 1-inch retention standard forwarded in the MS4 permits and the Mass draft. We are just introducing a new way of modeling that is more sophisticated than the single event-based design approach or the NRCS style approach that you may be familiar with. It's a lot more tied into kind of the continuously simulated rainfall. So we used a 29-year rainfall record, and that is all embodied in the tools that we developed to help you meet these standards. But from a design perspective, the first step is always site design. In some areas, we call this environmental site design or sustainable site design, where overall we're referring to this as low impact development design. So it's utilizing the existing sub drainage areas in the pre-development condition, matching those and trying to minimize the disturbance from the built condition from the pre-development condition. So this is hard to regulate, we understand, but it's where you can do a lot of work. And it's where historically, I think we've seen some shortcuts. And so that is really step one, is honoring that site design process and the efficacy of advancing these kind of more mature, more sophisticated concepts with respect to site design. The next is this retention standard or the watershed protection standard, and that is to really storing that 1 inch or the equivalent of a 1 inch rainfall. It differs based on soil type, but it's to retain that on site so that it doesn't lead to export of nutrients in particular. Step 3 is we do understand that there are instances where you can't do that on site. Maybe in a redevelopment condition or where there's other site constraints, such as areas of high potential pollutant load. We wouldn't be asking you to do on-site retention at a gas station per se. So in those instances, we're using the updated performance curves in the MS4 permits for Mass and New Hampshire to meet a 90% TSS reduction, a 60% phosphorus reduction, and a 50% nitrogen reduction. And the 50% nitrogen reduction is very, very, it's really targeted at the seacoast area of New Hampshire, which is the fastest growing, and also coastal drains to the Great Bay, which is impaired and threatened from excess nitrogen. So other requirements, the peak flow controls for the 2, the 10, 25, and the 50 have not changed. We have changed. We're recommending continuing to use Atlas 14. And we're recommending using those return intervals or the fitted values to control peak flows and also do your stream bank protection or channel protection volumes. Next slide. So a little bit on the pollutant curves. If you haven't seen these, I'll also drop a link to our website where there's vast amounts of resources that explain the performance curves. These are embodied in Appendix F of the New Hampshire and the Mass MS4 permit, and they really are a more up-to-date way of categorizing and quantifying the load reductions associated with a range of different structural controls. So if you paid attention to what's really happening in kind of throughout the country, you'll see, like, for instance, the recent Supreme Court case, EPA versus San Francisco. San Francisco was suing EPA over a narrative environmental standard, right? Or maximum extent practicable is something that we talk a lot about here. That's very kind of dubious and hard to nail down. What does that actually mean? And it leads to a lot of ambiguity with respect to the regulated condition. In New Hampshire and Mass, because EPA Region 1 has been so involved, we're really moving beyond these narrative standards into a numeric criteria. And that numeric criteria embodied in those load reductions, the 90, 50, 60, can all be quantified using these performance curves. So not only are we giving you a numeric criteria, but we're providing ways to calculate that for a range of structural controls across a range of different soil types. And you'll see that we're moving sort of beyond some of the conventional approaches, what we would otherwise have called the water quality volume, which was typically developed from a rainfall frequency analysis and targeted on 90 percentile storm event, or in most cases in New England, it's anywhere from 3/4 of an inch to 1.25 inches. Most hitting that 1-inch criteria. Yeah, for the most part, it's water quality volumes have been around 1 inch. And here we're providing some flexibility to use the curves to meet the numeric criteria, and still designing systems that could fall aside, like outside of that 1-inch criteria. So the 1-inch criteria, again, was useful at the time, but now with the more sophisticated modeling, we can take advantage of some of the dynamic processes that are happening in these systems. For the most part, the water quality volume was a static volume that was plunked into your system. And there's some inefficiencies there just from the modeling perspective. That's not quite how it happens. You know, the 1-inch doesn't just instantaneously fall from the sky and get delivered to your treatment system. So we're using this advanced modeling approach to take advantage of some of these more efficiently modeled hydrologic and hydraulic properties of treatment from these stormwater control measures. Next slide. When it comes to climate change or addressing larger storm volumes, so we're moving away from the TP40 and into Atlas 14. AOT has made this change at least 5 years ago for the state. And we're recommending Atlas 14 or also the Northeast Climate, the NRCC, Northeast Regional Climate Center, or the Cornell Atlas is also something that we accept, but we included and focus on Atlas 14 because it was a NOAA product, and we were at the time pretty sure that these products would continue to be invested in. And we know that NOAA is working on Atlas 15, and that's something that when and if that becomes available, we will update this guidance in the subsequent 2 years. We're also looking at this fitted value, which is the largest value. So when you look at these charts, we're focusing on these return intervals, these 24-hour return intervals to define the controls for the 2, the 10, the 25, and the 50-year event. And we're focusing on that fitted value. So the other two values you see are the upper confidence interval and the lower confidence interval. And so if you wanted, you know, more control, I guess you could adopt the upper confidence interval, like has been proposed in Massachusetts. We just felt using that fitted value is still a viable approach as long as you're using an updated rainfall atlas. Next slide. All right, and then I think rounding this out, we've also added kind of tiers to help you identify and target different stormwater controls. So in the way back in prior to the 2008 update, when we were using the New Hampshire Green Book, you know, it was just like provide stormwater controls and provide peak flow control. The 2008 handbook really advanced this water quality requirement and the water quality volume. And we said, well, in order to target that, it's best to use filtration and infiltration systems. Now we're defining that even more clearly. Instead of just filtration and infiltration systems, we're separating these into tiers. Tier 1 being systems that can typically be designed to meet all the requirements. So watershed protection standard or the pollutant load reduction requirements, groundwater recharge requirements, and peak flow as well. So they can be designed to meet everything. Tier 2 might be systems that can meet one or more of the criteria. And for these, I particularly think of systems that might not infiltrate. And if you're dealing with restrictive soils or you're not infiltrating, then you're unable to meet either a groundwater recharge requirement or a retention standard. So the tier 2 might provide treatment for one or more, but not all of these controls that we're looking for. And then tier 3 stormwater controls are things that are kind of falling out of favor. It offers the lowest level of pollutant reduction and may not really it shouldn't be considered really as primary treatment. And then there's non-applicable. These are things that we just can't really calculate or quantify and might be part of your treatment train or your overall management system, but in and of themselves wouldn't really yield or add to any of those kind of more numeric requirements. All right, next slide. And so you can see just examples here of some of the charts that are available in the manual. On the far left, we have the actual structural treatment and what in the name. So bioretention systems, and note it says infiltrating, not to be confused with biofiltration that might not infiltrate, which would probably be classified as a tier 2. Gravel wetlands, you see they're tier 2, even though they're one of the top performers for water quality, that they're designed at least by their nature to have a restrictive subgrade or restrictive subbase, such that you're not really requiring infiltration. And that's to maintain an internal storage reservoir. So they wouldn't really be able to meet groundwater recharge. You could couple them with other systems that could do that in tandem, but alone it wouldn't be able to meet the groundwater recharge requirements. And then sand filters, which are tier 3. These are things that have kind of been in the literature, but have fallen out of favor. Sand filters are kind of an enigma to me, unless they're manufactured. Sand filters often become bioretention systems. So, we're sort of classifying them as tier 3 anyway. And you can see as you move to the right here, we have all the attendant alteration of terrain requirements and their ability of these structural controls to meet those. Next slide. All right, and then here is just with respect to general nitrogen, phosphorus, sediment, metals, and bacteria removal, what these systems look like. So again, bioretention system that's infiltrating can meet all those. That would be your tier 1 system. A bioretention system that doesn't infiltrate, that would be lined, or that that would be in soils not suitable for infiltration, probably couldn't get the range of water quality benefits. And then you can look at things like extended detention, which historically we relied significantly on. As you can see, it doesn't have the capacity to really deal with many of the updated water quality parameters. Next slide. All right, so one of the best, I think, components are in our appendices. We've updated not only the descriptions of the stormwater control measures, these structural controls, but we've also updated the graphics, which is very near and dear to my heart, because I got pretty tired of looking at old depictions of these systems, begged and borrowed and stolen from various manuals throughout the country that didn't really accurately reflect what these systems look like. So we developed new schematics that accurately reflect what these actually look like in the field. So in this case, you're looking at a bioretention system, and notice it has an elevated underdrain. We're not putting the underdrain at the bottom, and that is to enhance infiltration. So the updates to the system, the stormwater control measures and the graphics and the fact sheets that are in Appendix A are one of probably the best attributes of this manual. Next slide. And then, yeah, as far as new content, we've added things around inspection and maintenance, and the requirements associated with meeting. Inspection and maintenance is something that I think we have a lot of progress to make in moving into the future. But if you are maintaining these systems, you still have the maintenance requirements are that you still meet some of the existing RSAs. And we've seen some maintenance done at times that disturb wildlife and other times that might not be really conducive to maintaining proper habitat and respecting the wildlife cycling. And so you're still having to meet some of these other RSAs that are associated with just disturbance overall. Next slide. And then Appendix B is erosion and sediment control measures. We did update this, so we've really eliminated straw bales as a BMP for erosion sediment control, advanced some of these new practices like the mulch berms or these filter log berms, potentially in combination, but hopefully not silt fence alone. So we have updated this. We do think that moving into the future, there'll be a lot more updates on the erosion sediment control practices moving into like year 2 review. But this is all associated with Appendix B, and there are updates that you might want to take a look at, consistent with the 2022 construction general permit issued from EPA. Next slide. And then as far as formatting changes, it used to be 3 manuals. It's 1 manual now. It used to be printed. Now it's available online. We're moving into the digital age. I know you can print it yourselves. We just have not printed hard copies. So it exists online as a digital resource, and it encompasses all the benefits of a digital resource in that the hyperlinks are all active and linked to various other resources that are accessible through this document. Next slide. Again, some of the look and feel has changed too. There's a new color scheme, the searchable headings. There's examples. The New Hampshire Plus icon, again, like I said, denotes things that are more of the latest and greatest research. Call-out boxes for key concepts and example calculation. And yeah, flip it one more time. And again, Appendix B, we've completely restructured the fact sheets for all the different structural controls. So has updated formatting, it has all kinds of information about the expected performance, and things like design considerations, maintenance considerations, and still a lot of useful updated information that's very specific to each structural control measure category. Next slide. And yeah, updated maintenance requirements and updated schematics, which again is something that I was very happy about. All right. So this is where I handed it to you.
All right. Thank you. Thank you, Jamie. Thank you for that overview of the manual. Now we'll go a bit more into the weeds here, and we'll talk about the alteration of terrain. So basically, how does the manual connect to AOT? Oops. Next slide. Okay. Okay, so as Jamie and Deb both mentioned, the manual is not a regulatory document. So all AOT requirements are not included in the manual, and designers should directly reference regulations, such as the AOT. But that being said, there are several references and connections to AOT that the manual makes. So this table here is showing just a sample of some of those topics, so kind of some of the key topics here. So, like an overview of AOT, where that references in the AOT program, where it is in the manual, and there's just several references to different design criteria for AOT. So, so the manual covers this in detail, how to do the water quality volume, how to do groundwater recharge calculations, channel protection, peak runoff control, what the different AOT documentation requirements are. So there's, definitely lots of connections that the manual makes to AOT. And there's some other places where this is shown. So as Jamie went over the SCM table earlier, so we have a table that shows all the different SCMs, what their tier is, and then it also talks about whether or not that SCM could meet AOT criteria. So for example, for pollutant removal, recharge, channel protection, or peak control. So, in this case, an infiltrating bioretention system would be expected to meet all of those criteria. And then there's a table also in the Appendix A for each individual SCM fact sheet, which also just indicates whether or not it would be, could meet those AOT design criteria. This table here is showing some of the differences in how AOT handles different design criteria versus the state of the practice guidance in the manual. So you'll notice, for different SCM design elements, AOT, is more, has more traditional design elements, whereas the manual has the call out with the New Hampshire Plus icon for different state of the practice elements. And I'll go into some of those examples in the next couple of slides. Same thing for pollutant removal and groundwater recharge. AOT, has that 1-inch water quality volume requirement, and then just some specifics for how to handle total phosphorus and nitrogen. The state of the practice recommendations in the manual try to simplify things and just recommend that sequential watershed protection standard design approach that Jamie went over. And same thing for the groundwater recharge, and I'll go over some examples in the next couple slides. For peak runoff control, the AOT requirements, are that the post-development peak discharge is less than the pre-development for the 10 and the 50-year 24-hour storms. The manual state of the practice guidance basically has some recommendations in there just to consider designing to a higher rainfall depth, such as the 100-year storm. If you have a site that could discharge to a sensitive receiving stream or location. So, for example, if you have a really highly urbanized area downstream of your site, it doesn't have a lot of floodplain storage. That could be a good reason to try to design your site, to the 100-year storm. Or if your site is discharging to a really small stream and intermittent stream. Okay. As Jamie mentioned earlier, the manual has the state of the practice icon here. And that's just going to identify any criteria in the manual that would exceed or differ from AOT requirements. All right, now we'll go into some examples here. So we'll go into some examples of looking at the AOT requirements versus the manual state of the practice recommendations. So we'll start off with gravel wetlands. So the AOT requirements, are generally very prescriptive on how to size these things. And so one example is having 2 treatment bays, each of which can filter a certain amount of water quality volume. The manual state of the practice simplifies some things here, basically just indicating to use those EPA performance curves to calculate the pollutant removals. As we go into bioretention systems, here's just one example of a filtering bioretention system. So the AOT requirements, there's some requirements about, having filter media depth, different mixtures, and then there's some vegetation requirements from 1988. So the manual just updates this. So recommending to use the 2021 Stormwater Center bioretention soil mix specification. There's some different recommendations on the depth of the soil mixture depending on the planned vegetation survival. There's also brand new planting guidance. So looking at New Hampshire specific guidance, and it's got a nice it's set up for different things, like if you want to use plants for more shade versus sun versus salt tolerant. So it's been completely revamped. And then, as Jamie mentioned, under drains are definitely important. So under drains can cause a lot of benefits, in basically improving water quality and just hydrologic performance. So by raising that under drain up just a little bit, we can really enhance increased infiltration, which would then result in greater runoff reduction and just a slew of other benefits. So for pollutant removal, the AOT has several requirements for phosphorus impaired as well as nitrogen impaired watersheds. The state of the practice recommendations tries to simplify this by going for that sequential watershed protection standard design approach. And the idea here is that that WPS would meet the 1-inch retention, which would then exceed any treatment requirements for that there are. Groundwater recharge is similar. So the AOT requires that the groundwater recharge volume be calculated based on hydrologic soil group, and then each soil group would have a target recharge depth. So soil group A would have a target of 0.4 inches. The manual just recommends using the WPS, which will get you to that 1-inch recharge volume, which would meet or exceed the AOT requirements. And with that, I will invite Mike just to talk a little bit about some of the other AOT pieces.
Thank you. Yeah, so as previously noted, the Alteration of Terrain Bureau worked closely with the Stormwater Group during the development of the Stormwater Manual, and we're in full support of it and its contents. Also noted, we are a regulatory agency, so the rules will take some time to catch up to any of the newer stuff that's in the manual. So, in the meantime, I would encourage you to use a waiver. We do have a waiver process that you could submit a waiver request with your application if you are proposing something that's not currently allowed in rule, but is an option in the Stormwater Manual. And I would encourage you to reach out if you have any questions during the preparation of your AOT application, but specifically if you are going to request a waiver, please reach out ahead of time just to discuss, what sort of support or what, let us know what path you are going to take so that we can come to an agreement before you submit the application. That will save some time in the long run. Thank you.
All right. Thank you, Mike. All right. So now we'll move on to some technical examples. So we'll get a little bit into the weeds here, but hopefully not too much. We'll try to keep it high level. But the idea here is just to show some examples of how the design criteria could work in practice for sizing in SCM. So let's just imagine that we have a really simple project site. So it's 1 acre. It's an existing forested, site, and you want to turn this site into a parking lot. So we'll just make it into a completely impervious parking lot. We're going to put a infiltration SCM over here on the right-hand side to capture the runoff from that parking lot. So we want to figure out what the required design storage volume of this proposed infiltration basin will be to meet different design criteria. So we'll look at the watershed protection standard. We'll look at the groundwater recharge volume, and then we'll look at pollutant removals. And just for simplicity, we'll assume that soil testing has been done at the location of the infiltration. SCM is determined to be soil group B, which has a hydraulic conductivity of 1.02 inches per hour. So we'll start off with the watershed protection standard. As Jamie mentioned earlier, the UNH Stormwater Center has built a WPS calculator tool. So this is just an Excel-based tool, and it really simplifies the process quite a bit. So you start off with your inputs, so just, what's your site name, what's your impervious area. There's a drop-down menu here, which you can select your SCM. So in this case, we would select surface infiltration. We can put in our infiltration rate right here. And I should also note here that I'm just showing an example for one SCM in one drainage area. If you have a more complicated site, this spreadsheet tool expands for a lot more SCMs. So I think it's got space for up to 10 SCMs or so. So once you've got your inputs, it's going to work some magic in the background and come up with what the required design storage volume is to meet the watershed protection standard. And what's exciting about the watershed, about this calculator and in general, what's exciting about this in general is that, the retention goal is 1 inch. So the static retention goal is 1 inch, but because the WPS has been built using continuous simulation methods, we can kind of gain some, essentially make the sizing smaller. So in this case, we've got a physical storage capacity here of 0.6 inches as opposed to that 1 inch. So this is going to meet that 1 inch static retention standard. So basically just means that your SCM is going to be much smaller, more efficient. The WPS calculator also calculates pollutant removal. So it uses a lookup table for those EPA curves. So you can just automatically figure out, okay, based on this storage capacity of being able to capture 0.6 inches of upstream impervious surface, we've got removal efficiency of 94% phosphorus, for example, and 97% TSS. So it's a pretty slick, really easy to use tool, which I've, since it's been built, I find myself using it more and more every day. Okay, so the EPA performance curves that Jamie went over, I'll just go over a quick example of how that would work here for sizing our example SCM. So we want to come up with the design storage volume to meet that 90% TSS, 60% phosphorus, 50% nitrogen removal. So all we do is, we'll draw some arrows on the curves here to our desired load reduction, in this case, the 90% for TSS. We'll figure out what the depth, essentially what runoff depth this has to capture from the upstream impervious area. In this case, it's about 0.18 inches. We do the same thing for phosphorus and nitrogen. And what we want to do is just choose the largest one. So essentially that just shows that this is going to meet the 60% phosphorus removal standard. It will slightly exceed TSS and nitrogen. So this ends up with a design storage volume of just 726 cubic feet. So we can see that's a lot smaller than the watershed protection standard. So if you're just sizing for pollutant removal, the overall storage volume of that SCM can be a lot smaller. Now we can go into sizing for groundwater recharge. And I'll go over several different methods here. So, the first one is AOT, where, this is just calculated based on the amount of impervious surface and then the required depth of runoff. And that's, based on the hydrologic soil group. So in this case, it's B soils. So that target recharge at this 0.25 inches. So we end up with a required design storage volume of 908 cubic feet. So about half the size of the watershed standard. There's a couple other ways to calculate recharge. So Massachusetts has a static sizing method, and they have a target depth factor of 1 inch across the board, and that will likely change to 0.8 inches based on public comments, but that regulation is not out yet. But the idea here is you're going to take your target depth factor of 1 inch, multiply by the impervious area, and you're getting 3,600 cubic feet. So by far the largest required design storage volume. There is another method in Massachusetts where you can do what's called the simple dynamic method. So essentially you can calculate your design storage volume as a function of the bottom area of the SCM, the depth, and the hydraulic conductivity. So that can decrease your required sizing by just a little bit. So going from 3,600 to 3,400 cubic feet. So what this shows us here is, that static sizing is going to result in the largest SCM footprint by a long shot, and then you can go down to simple dynamic, which will marginally decrease your SCM footprint. And then the watershed protection standard, which uses those long-term continuous simulations, you're going to end up with a design storage volume of about 2,000 cubic feet. So again, it kind of shows that just by doing some more sophisticated modeling, your SCM can meet the same goals as static sizing by using this WPS tool. And then the AOT groundwater recharge volume is the smallest. So if you were to design your SCM to meet the WPS, you will, effectively meet the AOT as well. All right, so now we know all of our required design storage volumes for all these different design criteria. So, if we want to meet all the design criteria, the WPS is the largest volume, so we'll size our SCM based on the WPS. And again, if for some reason there's not space on the site to be able to meet the WPS, maybe there's poor soils, the groundwater table is too high, then the whole idea is that this is it's a stepwise process. So if you can't meet the WPS, then you go to the pollutant removal for your sizing. So in this case, there's a lot of different ways where you can size an SCM, but there's one really simple way is to use the New Hampshire MS4 permit. So there's basically just a table in there which shows the different sizing calcs for different SCMs. So in this case, we can size our infiltration basin based on that. So we'll come up with a length of 40 feet. We'll give it some depth. We'll give it some gentle side slopes, a bottom width, and then we can essentially plug those into this equation here and come up with a design storage volume of 2,200 cubic feet, which exceeds the required WPS design storage volume. So we're good to go there. And the last thing that you want to do is just double check that the SCM is able to drain within 72 hours. So you could just plug that into a simple formula, which is, looking at your design storage volume and your infiltration rate and your bottom area. In this case, we've got our SCM is going to drain in 67 hours. So we are all good there. And then again, one of the important things to note here is that if you're sizing your SCM to meet the WPS, then by default, you're going to meet the pollutant removal and the groundwater recharge volume standard under AOT. So one other important thing to note here is I just went through examples of how to meet certain design criteria, but you would also still have to design this SCM to meet the peak rate and the channel protection requirements. So that could change the footprint a little bit. and more than likely it would just require some tweaking of the outlet control structure to make sure that those requirements are met. And with that, I'll hand it over to Deb to talk about MS4 compliance and municipal resources.
Great. Thank you, Dave. Thank you for all that information. All right. In the interest of time, I will go over these next slides relatively quickly because I want to make sure that we have enough time for Q&A. So next slide, please, Dave. Thank you. So just want to bring attention to some stormwater site plan regulation updates. The UNH Stormwater Center actually has a draft model post-construction stormwater management standard that you can use for site plan review regulations. And you'll see on the right-hand side, there's a QR code and also a direct link should you want to look there. And UNH Stormwater Center will be updating that as they continue to input additional information and finalize it. So this provides recommendations for stormwater management, for new development and redevelopment, and it's generally consistent, and with a lot of times it exceeds the requirements that we're seeing in a lot of these stormwater permits, such as the draft 2024 Mass MS4 permit that Jamie was referring to. And I don't want to assume everyone knows what MS4 stands for. It is an EPA federal permit. MS4 stands for Municipal Separate Storm Sewer System. And if you still don't know what that is, be very grateful because that means that you're not involved. But anyway, so there's some really great information on site design, water quality standards, stormwater management criteria, inspection and maintenance responsibilities. So highly encourage you to check that out. Thanks, Dave. Relative to New Hampshire MS4 compliance, there's a lot of really great resources. So if any of you are consultants or municipalities who are MS4s or working for MS4s, we again remind you that there's some really great resources that can be found. Each of these links on the slides are live, so you can just click on them on the presentation. But the first one is the New Hampshire Stormwater Regional Coalition website, which is housed by New Hampshire DES. UNH Stormwater Center also has an MS4 dedicated website. And then EPA Region 1 also has some really great stormwater tools. Even if you're not an MS4 regulated permittee, I would encourage you to look at these resources because there are some phenomenal tools. We have some great education tools. We have some really good templates that you can use. So I encourage you to check out any of those links. Municipal stormwater management programs, Jamie alluded to this a little bit earlier. Again, we took a lot of focus on, trying to provide everybody holistically some really great tools, whether you're permitted by a state or federal agency or not. You just are really cognizant and about water quality and also stormwater management. So chapter 2, section 2.2.2, you'll find a lot of this information and then links contained within, but great information on our stormwater asset management, stormwater utilities, IDDE programs, New Hampshire Green Snow Pro, which happy to say that New Hampshire DES now has a municipal Green Snow Pro program to reduce salt and be smart using salt. A lot of public education and outreach materials, templates for municipal ordinances, and then some examples of easements and deed restrictions. So you're saying, this is all great, Deb and Jamie and Dave and Mike, but we want to do it all, but we need money. So I'm here to tell you I can provide you with some opportunities to consider. So in the manual as well, we have links and resources where you can go to look at potential funding resources relative to stormwater management and water quality improvements. So as far as New Hampshire DES, we have a few. that are managed through our watershed assistance grants. We have water quality planning grants. We also have the Clean Water State Revolving Fund as well, and then some coastal resilience grants. And again, we have a variety of other potential resources as well. So I just want to talk very briefly about two that I'm very involved with. So the first one is the Clean Water SRF Loan Program. While it is housed and managed through the Wastewater Engineering Bureau, there is a stormwater section. And when we talk stormwater, it's inclusive of non-point source as well. And the variety of categories that we provide funding for is asset management, planning, infrastructure with planning components, and infrastructure projects. So we just finished up our 2025 solicitation. Actually, I just sent out congratulatory letters this week for those that were authorized. So I don't have definitive dates for 2026, but I can tell you we're already planning here at DES and getting ready for our 2026 solicitation. So I can give you some general guidance. Our annual solicitation typically occurs around March. That's when we start announcing on our website. We do blast emails. We have an annual water infrastructure webinar series. It's a week-long series. It contains a lot of really great presentations on a variety of resources and project types, both for the Clean Water SRF program and the Drinking Water SRF program. For the Clean Water SRF program, pre-applications are typically due on or around June 1st. It is a competitive loan process. And just so you're aware, eligible applicants can only be government entities if you want to receive the principal forgiveness. However, we've been pretty creative in finding ways to work with other entities through the municipalities acting as fiscal agents. So if you want to know more about that, feel free to reach out to me. And again, the link on the bottom will bring you right to the overall Clean Water SRF program here in New Hampshire. The next funding source is housed within the section I work in too, is our EPA grants, 604B and 319. So each year, New Hampshire Department of Environmental Services receives pass-through grants from EPA to fund projects to conduct water quality planning or implementation projects. So here is some more information. My apologies, that previous slide will bring you right to that web page with additional information. So just so that you're aware, the 604B grants are for planning projects, and then the 319 are for implementation or construction projects. We typically publish this information and announce it on or around late June or early July. However, this year, we are delaying the release because of funding uncertainties. So we're still holding on to this year. I highly encourage you, if you are interested in any of these opportunities, 604B or 319, that you continually look at our website. Again, that was on that previous page, because it is my understanding that as soon as we get some more information, we will be releasing and looking for letters of intent. Eligibility for applicants, you can see the list is much greater. It includes state agencies, watershed associations, regional planning commissions, and more. If you want to find out more information, there's some contact there with my colleague, Andrea Betlick. Feel free to reach out to her. All right, next steps. So effective date of the manual, again, was February 2025. So if any of you are holding on to that old 2008, although we loved it so much, it serves its purpose. But if you have any hard copies or you have any printed copies of 2008, please discard it, recycle appropriately, use it as bookends, whatever. Please use and reference the February 2025 updated manual. We're going to continue to provide upcoming outreach sessions such as this. You can look on the UNH Stormwater Center website. We update it as soon as we know that we'll be doing additional outreach sessions, and we are planning, over the next many months to continue letting people know. CEI is going to be putting together an FAQ document based on all of the outreach sessions that we are doing, the questions that come up and responses. So that will be posted on the UNH Stormwater Center website as well. And then lastly, the 2025 manual will be reviewed and updated periodically. As I had mentioned earlier, the plan is about every 2 years so that we can stay up to date with the current regulations and the state of the science. Okay, I'm now going to pass it over to Jamie Houle, who is going to facilitate the Q&A. I think he's going to start probably with the chat questions, and then we'll have an opportunity for folks to raise their hands. But thank you, everyone.
Great, thanks, Deb. Yes, so we managed to stay up to date, updated with the answers to questions in the chat. There was a few on, is there template language available to include the watershed protection standard in our local ordinances? And we provided links to that in the chat, as well as in the presentation, which will be uploaded. I think Elvina provided a location where this presentation will be available. It's also available on our website, and I can drop a link in the chat to our website. And I'm also just putting in another resource that's out there is NEWIN. So in addition to the New England Environmental Finance Center, they run a program called the New England Water Infrastructure Network, NEWIN. And that is, I just put a link to that website. They can provide technical assistance to update your regulations. So that is something that they access things like the SRF in order to provide resources for planning. And one of those projects could be updating your regulations. So we could provide potentially technical assistance for that. So I put the link in there for that. And then I don't see any other questions that were unanswered in the chat. So if you do have any additional questions, drop them in the chat. We'll be quick to respond, or we'll just do it in real time. Otherwise, now would be the time if you want to ask it to unmute yourself and ask away.
Unfortunately, this platform doesn't work that way. People are not able to unmute themselves. So we'd rather have everybody put their questions in the chat.
There you go. Don't unmute yourself. Put any additional questions in the chat. Right, it is a lot to take in. We were working for almost 3 years on this. So we understand it's a lot to take in initially. Hopefully, this document will provide hours, if not years, of resources for you.
And I would just add on to that, Jamie, after now you've had the presentation, you get a little flavor of what's available. When you delve into the Stormwater Manual, if you have some questions that you'd like to discuss with us further, please reach out to any of us. We're always very happy to discuss any content of the Stormwater Manual. It is pretty near and dear to our heart.
Right, a link was just dropped in the chat to fill out the webinar survey feedback. And I'll just add that one of the reasons why we particularly want to reach out to planning professionals is, probably the number one thing you can do to protect water quality now and moving into the future is to update your regulations so that when development and redevelopment happens, it's being implemented with the latest and greatest strategies to protect water quality and control water quantity. So you guys are one of our target audiences for sure. So James asked a question. We are being offered 700 feet of private road to consider as pervious asphalt. That seems like a monumental maintenance requirement. Any thoughts in the manual on how to determine when pervious asphalt is viable? Okay, great question. So 700 feet of private road, I think the issue really is with respect to maintenance. Does the manual really address all the maintenance criteria and all the nuances associated with inspection and maintenance? No, it does offer the, go-to resources that should be implemented with various technologies. So permeable pavement, the idea is you need to vacuum that and like a vacuum sweep at least once a year. We've seen people struggle with that. We have a residential development with about 700 feet of private road here in Durham. And my recommendation to that homeowners association that adopted or received the maintenance program for that facility was you likely will have a hard time contracting someone to come and do that with a vacuum sweeper. However, you could purchase a $400 yard vac and have a high schooler basically vacuum that pavement once a year. So I think there are various innovative ways to maintain these types of facilities. And as they emerge, I'm sure the inspection and maintenance market will grow to be able to meet the needs. But again, in the interim, it could be something as simple as that. And when we think of a roadway, a permeable roadway, not all that space is created equal. So, the center line of that crown roadway might not need to be maintained at all. It could be, you need to vacuum the gutter line. So, or the low spots, there are various areas where you might have enhanced maintenance, such as where vehicles track on sediment and other debris from impervious roadways, such as the entrance and the exit of that private road. And then things like leaf blowing. The whole idea of the permeable pavement is to not allow accumulation of material to collect for long periods of time so that tires can grind that material up and embed that within the pore spaces of the media or the asphalt surface. So you can do that with leaf blowing in the fall, and it could be a combination of efforts. So that's something I could offer up. We do know that many permeable pavements go unmaintained for long periods of time, and that used to really keep me up at night. There are technologies out there that have the ability to restore pavement, and we've experimented with those from the university at the University of New Hampshire, and we've had 10-year-old neglected permeable pavements that have been nearly completely restored with some of these new technologies. So I would say there's two types of real maintenance with respect to permeable pavement, which again, something like the manual probably in this round didn't go into great detail on, but one is preventative maintenance. That's keeping that material off. And again, that's something you can do with leaf blowing or vacuuming the gutter line or a combination of those activities. It doesn't have to be with, some huge piece of equipment. And then secondarily would be restorative maintenance. So in the event that you completely neglect that technology and you have to restore the infiltration capacity, that can be done. Obviously, preventative is much cheaper than restorative, but we know now that both of those scenarios can be maintained. Next question is.
Well, Jamie, sorry,
Yep.
before you go there, I know a question I get a lot too is, well, any considerations that folks should take relative to winter maintenance with these permeable pavements?
Oh, so winter maintenance. One of the advantages of the permeable pavements is the snow piles on the side of the road after plowing do not really kind of disappear over time, or there's benefits to permeable pavement because, again, during those diurnal freeze thaw patterns, so oftentimes we get into these patterns where you have piles of snow in the day, they thaw from sunlight and they leak onto an impervious area, and at night they freeze. And we call that phenomenon black ice. That is really what causes probably the most hazardous conditions with respect to a roadway or pavement, on a driveway. So that doesn't happen on permeable pavement. So there is evidence out there, and there's signs. Some of it was produced at UNH that show a reduction in chloride. For the most part, we don't recommend necessarily that you partake in a research project on your own. We recommend it to be managed just like you would any other pavement. But I think you'll find with more attention to that maintenance that there'll be added some opportunities for reduction of chloride. The other thing I'll say is chloride doesn't work on a permeable pavement the way it works on a dense pavement. If you think of broadcasting salt on a permeable pavement, it hits the ice and it melts and it creates a brine that spreads over the impermeable surface. That's the conventional way. In a pavement, you'll broadcast the salt, but it won't create that liquid brine because the underlaying material is permeable. It'll just go right in. And so you'll have this pop mark kind of I guess kind of scenario. That said, it's enough to break up the integrity of the ice so that more mechanical operations such as plowing, so more plowing would be beneficial as opposed to more broadcasting of the chemical. So again, this is somewhat emergent. I think there are ways to manage that such that you can reduce the amount of chloride in application, but I think the simple answer is we don't initially recommend treating it differently. All right, so next question, could we invite someone to come to Raymond to present the manual for the planning board? They would benefit from an overview of these topics. Deb?
Yes, thank you, Jamie. Yeah, I think we absolutely could do that. It likely may not be the whole wealth of us, but we can certainly talk about who, when. So let's see, it's James. If you want to reach out to me to schedule that, we can work something out, and I will put my email address in the chat.
Yeah, and one other way that you could at least expedite that is put in technical assistance to NUIN and ask for that exact activity. And then something like that, if you go and fill out that technical assistance form on the NUIN website that I provided a link to, and if you scroll down, there's a button on the left that says request assistance. It'll lead you to a web form that you can fill out. And if you put in a request to have someone present this material, not only will that demonstrate that their expenditure on this outreach and education was meaningful, but it's actually leading to change. So that would you know, they would email me and say, can you go to Raymond? And I'll say, absolutely. And Deb put her email in the chat as well. All right, we have about a minute left. I guess if anybody has any burning questions. Looks like one more just came in. Who would you recommend to perform an audit of our zoning regulations? Suggest ways to go beyond and eliminate outdated language. Yeah, I think, I don't know, my primary recommendation would be to go to that new insight and fill out a TA assistance form. And that will at least give you an idea of, you know, where you are, whether, you know, and what level of effort. Is this a complete overhaul? Like these were written in the 1950s and, you know, really need to be updated, which isn't a bad thing. I think you leapfrog into the latest and greatest science, but that would be one way. And Deb, I don't know, is there any other way? Reach out to you and talk about a planning grant, SRF grant, possibly to do the same thing?
Yeah, no, that would absolutely be an option. And what I love when people reach out, it's never too early. I tell them I'm already talking to people about the 2026 pre-apps. It seems far away, but it's not. And we can start brainstorming on a potential project, and would likely include maybe a little bit more. We could dig deeper into what the project would actually entail. The other option I'm thinking of is reaching out to your regional planning commission. They may be able to provide some assistance as well.
Great. All right, we're officially 1 minute over, but we really want to thank you for your time and appreciate the opportunity to occupy your lunchtime.
Yes, thank you.
All right, thank you to our speakers, and thanks for everybody who stuck with us till the end. And yeah, we'll see you all next month. All right, thanks everybody.